Good evening, everyone. Hey, welcome from the TreeStuff World Headquarters in Boise, Idaho. Nope, that's just a joke. My name is David Anderson, and I'm speaking to you from an office where I get paid a paycheck every day to study birds of prey, like eagles, falcons, and hawks and stuff, in places like Alaska and Panama and the Dominican Republic. But my alter ego is Canopy Watch, where I teach tree climbing and teach about the ecology of forests. And I'm a scientist. I'm not an arborist. I learned climbing starting in 1995. A few things have changed since then. And as a scientist, like I've got 3 college degrees, which is more than is really good for you. Um, but but I've been climbing, for 25, going on 30 years now. And so I thought I could share. Nick Bonner asked me if I would give a talk today. And I thought I could share some fun stories about how arborists and scientists work together to study the natural world. And the first thing I really want to say is thanks to TreeStuff and Nick Bonner for inviting me to give this talk. My goal today is to have a lot of fun, to teach a few new things, and hopefully that you're all going to learn something and have fun and share this webinar with your friends. All right. So with that, the title of my talk, which I hope you can all see on the first slide, is Canopy Exploration and Science, the Beautiful Relationship with Arboriculture. And this is a TreeStuff webinar, and you can see my website, canopywatch.com. We'll talk about that later. It's there for education and learning, really. All right, next one. If any of you have ever been in a tropical forest, the first thing you notice when you walk into a tropical forest is that there are sounds coming from everywhere. There are bright birds flying around. There's monkeys howling. You can hear the insects and the birds are calling, and there's hoots and screeches and squawks and whines and all this noise and colored flowers. And this forest is really tall and complex. There's many layers, too many tree species to count, and it is so overwhelming. And the impression that you get when you walk into that forest is that there is a lot going on in this forest, and I can't begin to grasp it because I'm standing on the ground, and this forest may go 150 to 180 feet tall, and there's no way I can even see up there. So if we want to understand tropical biodiversity, it kind of hints at you that to really get a good idea of what's happening in the forest, you need to get off the ground. Next slide. I know a little bit about how well we can understand the biology of tropical forests and what happens in the canopy, because it was the subject of my doctorate degree at Louisiana State University. And being a bird person, I was a student of ornithology, the study of birds. I wanted to ask this question: how well can we understand canopy birds while working from the ground? And I did my research in this national park highlighted in that little green polygon in the top of Honduras, Central America. The park is called Pico Bonito National Park. And I spent a year climbing trees in Pico Bonito and studying the bird life there. So next one. To study the birds in Pico Bonito and to answer this question, how well can we study birds from the ground, I used 3 methods to study the birds. And we're starting with the first slide here that's going to show you the first method that I used. The green polygon is the study area, which was a 100-hectare plot, which is about 250 acres, give or take. And the yellow points are spots where I would walk on a transect and stop on the ground for 10 minutes. And I would write down in my recording, in my notes, every bird that I could either hear or see and identify. And the reason that I used this method is because doing point count surveys from the ground is like the global standard that people use for surveying birds. Everywhere, in prairies, in forests, in meadows, on the beach, that's what people do. And so I used this method as my baseline. And I said, okay, if someone were studying birds in this forest, this was how they would do it. I did 27 censuses at 30 of these point count stations for a total of about 67 hours. And pay attention to the yellow points in here because that color is going to repeat in a theme through the first part of the talk. Okay, next one. The next method, and I'm going to follow along on my own computer here. Watch this. The next method that I used, I'm going to call the repeat tree method, and you see two light blue squares in the slide. This method had only been used 3 times before to study birds of tropical forests. And in this method, you have a limited number of viewpoints. In my case, they were tree tops, and you would go to these points and survey them over and over and over. They were 1 kilometer apart. I did 22 censuses, and each census lasts 3 hours. Because it takes so long to get to the top of the tree, the survey has to start at sunrise, which means like I'm driving down the mountain in an old Toyota Land Cruiser, hiking through the forest in the dark, climbing at the first, gray twilight and getting into the top of the tree. So I sit there for 3 hours and study birds. And again, anything that I can hear or see, I recorded on an actual tape recorder, because this was in 2005, this particular study. And then would go back and transcribe my notes later. Okay, next one. The next method that I would use was, I just called it the single tree method. And rather than having 2 trees that I climbed a whole bunch of times, this is partly scientific method, and this is partly David Anderson saying, I really want to climb a lot of trees in the rainforest. I climbed 22 trees once each and did a 3-hour survey from the top of each tree. But there was a good reason that I did that. And it's because in a tropical forest, the resources that birds use are not evenly distributed. You might have a tree that's flowering over here and it's attracting hummingbirds. And on the other side of the plot, you've got a couple trees with fruit in them that are attracting toucans or whatever. So by spreading out my points, I got a better idea of what was happening across the whole forest. And again, in both the repeat tree and the single tree, it was 22 3-hour censuses for a total of 66 hours. Okay, next one. And then I want to show you a little bit about what it looks like when a scientist climbs trees. If you click, Kale, if you click on that, there should be a blue circle that, maybe not. On the left, okay, I can't see in my screen, thanks. In the left image, you see what looks like my rear going up a tree that's 130 feet tall, and I'm using stationary rope method or single rope technique on handheld jumars, literally the old yellow jumars, and a rock climbing harness to get to the top of the tree. I'm bringing up this point because climbing on a single rope is what most scientists do and what most scientists consider to be tree climbing. And that point's going to come back later in the talk too. All right, next one. During my work, this is cool. I had 5,400 detections of birds. So anytime I register, I hear a bird singing over here, that's a detection of 165 species that I could identify by hearing them or by seeing them or both. Of those 165 species, 118 I saw at least one time in the canopy. And of those 118, by some statistical methods, I determined that 65 of those can be called the core canopy species, the ones that are most restricted to or most representative of the top layer of tree crowns in that tropical forest. And, just for fun, there's flycatchers, there's toucans, there's hummingbirds, there's things like cotingas and tatiras and hawks and pigeons and cuckoos and puffbirds. The list goes on. Tropical birds are pretty cool. But anyways, 65 were the core canopy species. Okay, next one. All right, by now, I hope you're saying, God, I hope he gets on with it. Now it's time to where we can compare the 3 methods and how well each one was able to detect birds in the forest canopy. The dotted line across the top of the graph here is the 65 core canopy species, And on the bottom of the graph, you can see the number of detections, 1,000, 2,000, 3,000. And then if you'll click there, Cale, the first curve on this graph is yellow. Those are the yellow ground-based points. And I was only able to detect 46 of the 65 core canopy species from the ground. But if we go to the next curve, the light blue one, I was able to detect all 65 species, or with the pink curve in the next one, almost all of the 65. Next one, Cale, it's there. Almost the full complement of the, oops, one more, there we go, of the core canopy species. So obviously, I'm detecting more species while working in the canopy. Okay, next one. We got, this is teamwork here. Cale Royer is running the slides for us today. Another way to look at that is breaking down the number of birds that I'm detecting on an hourly basis. So if we take all of the detections over a whole year and over 180 hours doing surveys, the 3 bars on the left are the ground point counts, single tree and repeat tree. And those are the canopy species, the 65 core canopy species. And you can see that the bars are taller for the methods where I was working in the tree. So I'm recording more species per hour while working in the treetops. And then on the right side of the graph, I'm detecting more individual birds in the canopy while working in the tops of the trees than on the ground. So you see the yellow star on the slide. That is a reminder to me that I have to look at my notes. And it's a reminder to you to be taking your own notes. So the point of this slide is trying to study canopy birds from the ground as a method or technique is super el stinko. It's not good. If you want to study canopy birds, you have to get into the top of the forest, all right? Now, next slide. It's not going to surprise you that if you're in the top of a tree, you see birds in the tops of the tree. But let's talk about what the practical implications are of what do we learn about the individual birds while we're in the top of the forest versus on the ground. So this slide has another yellow star, wink, wink. This bird is called the lovely cotinga. Cotingas are these wild tropical birds that all have strange colors or strange habits or strange songs. It's like the one thing they have in common is that they're weird. And the lovely cotinga is the most shockingly beautiful bird in the whole country of Honduras because it has this turquoise blue, electric blue color with a purple breast and a purple throat. They are so blue that if you're in the top of the forest and you can see a kilometer way across the forest and you see this little glowing blue light bulb a kilometer away, you know automatically that's a lovely cotinga. While working from in the canopy, I knew where all the cotingas like to be. I knew where their fruiting trees were. I knew where they liked to perch. I knew everything about them. And even with that, information like up my sleeve, while working from the ground, I'd be looking up into the trees and I never once saw the cotingas from the ground, even though they're the most electric blue bird you could ever hope to see in your life. Next slide. But there's more to the story of the cotinga. The cotingas like to eat the fruits of this mistletoe, this red and yellow flower. And they don't swallow the seeds. They swallow the seeds and then they regurgitate the seeds back out. And the seeds are so sticky that a cotinga can't spit them out like it can other seeds from other fruits. It has to open its mouth super wide, which is something that cotingas do. They have like the biggest mouth anywhere. And then it wipes its beak, it wipes its mouth on the branch until those seeds stick to the branch. And guess what happens? The mistletoe grows from those seeds and sprouts new plants. And I detected 19 different species of birds, either drinking nectar from the flowers or eating the fruits of that plant. And all of those interactions between the birds and the flowers and the fruits were only made while I was working in the top of the forest. So working from the ground, I would have missed this whole picture. And my understanding of the ecology of the interactions between animals and plants in the top of the forest would have had this huge hole in it. So for their role, there's 2 stars on this slide. For their role in dispersing these seeds, we call the lovely cotinga a landscape engineer. Landscape, let's make sure I get that right. Landscape engineers are those animals that make habitat for other animals. Cotingas are making habitat for other birds that need these flowers. Examples from North America would be beavers, because beavers go into a watershed, they build a dam, the dam creates ponds, and the ponds create meadows. Now we've got habitat for trout, for mink, for deer, for songbirds, for predators, and for everybody else. So beavers are landscape engineers, and elephants are landscape engineers. They're so huge that they rip entire trees out of the ground, and they make big wallows in the mud that other animals come and drink from. So lovely cotingas are known as a landscape engineer. And the third one that happens in North America and strange countries like Canada and France, just kidding, and you're not going to believe this one. So everyone in the audience, raise your hand. If you're an arborist, you are a landscape engineer, because you have the opportunity to create or remove habitat. You may be working in a snag, and you may be able to leave part of that snag, if it's safe, as habitat for raccoons and other birds. Or maybe someone wants their tree taken down, and you can convince them that it's in the back of the yard, and you're going to reduce it to a spar and make some notches in it and create a snag for wildlife. So elephants, beavers, arborists, and cotingas all fit into this elite group of landscape engineers. Okay, next slide. And the next one with the map. There we go. As another example of what we can learn by working on the tops of the forest, in this slide, there are 3 species of lemurs, a type of primitive primate that lives only on the island of Madagascar, that were all discovered recently by biologists from the Peregrine Fund. These are species that were not known to science. Scientists, and outside maybe of a Malagasy person who found one by accident, maybe, nobody knew these things even lived. Where do they live? They live in the top of the forest. So there are new species of birds and insects and reptiles and even primates and mammals being discovered in the tops of the forest. But to discover those species and to understand the biology of up there, we have to climb. Pretty cool. All right, so let's go to the next slide. Okay, so there's going to be some animations here, and they're hard for me to see, but I'll just assume that they're going, and Kale will follow with me. The ultimate goal of a scientist is to build knowledge. That's what I do. I go out, I conduct research, I collect data, I synthesize the data, I publish the data and share it, and I build knowledge. But the quality of our knowledge is only as good as the quality of the methods that we use to gain the knowledge. If we're studying canopy birds from the ground, our methods are not good and our knowledge is bad. Therefore, if we can find any barriers to improving our methods, those are also barriers to improving our knowledge. And barriers to climbing in science is the next part of the talk. Okay, so next slide. So one question as a scientist who goes to conferences and talks with other scientists, and I say, so how do you climb trees? And they're like, man, I know all about tree climbing. I'm like, I'm not so sure of that. So I wanted to do some research and tease out different lines of evidence that tell us whether or not scientists are good at climbing trees. And the first line of research that I want to give you, or the first line of evidence about how good scientists are, is me personally, okay? If I don't want to be throwing scientists under the bus or anybody else unless I have thick skin and I can pick on myself. So there's a few pictures I want you to look at here. In the upper left and the upper right, those photos go back to 1996. When I was getting a master's degree studying birds of prey in a really remote rainforest called the Mosquito Coast, or La Mosquitia, in Honduras. And I thought I was a pretty good climber. And maybe if you're looking at those images, you're thinking, maybe not. So on the left, I've got this great big tree climbing saddle, and underneath that, I've got a rock climbing saddle. And on the right, you can see I was climbing these tall tropical trees with a hemp flip line with the wire core on the inside. I don't know how many people watching the webinar have climbed a tropical tree. There's like two kinds of wood. There's the really soft wood that gushes sap all over your clothes, and then there's the really hard wood that is like climbing a concrete pole and the spurs don't even go in. And I thought I was good at tree climbing. And then the photo on the bottom is me using my ultra sophisticated Jumars with a single rope technique. So I am an example in these slides of what scientists have named, psychologists have named, the Dunning-Kruger effect. And I'm going to follow along with my own slideshow here. The Dunning-Kruger effect simply is the difference between how much you think you know about something and how much you truly know. And psychologists have noticed that the less you know about something, the more you overestimate how good you are at that thing. And the reason is kind of obvious. If you don't have any information, you aren't able to judge how good you are or how bad you are. So go to the graph there, Kale, and click on the next one. Click once. Okay, you see the red dot. The red dots are going to track up the gray bar, which is how well somebody performed on a test of their knowledge or ability. Next click. And the blue is their actual score, their demonstration of their knowledge, and it's the gap between how good they think they are at, how good they actually are on the bottom and how good they think they are on the top. That is evidence of the Dunning-Kruger effect. And what you see with these two lines is that they cross, because the more you learn about something, the more you realize the limits to your knowledge. And it's those people who know the least think that they know the most. And anyone who has an arborist has experienced this before, I promise you. How many homeowners have said, arboriculture is easy, you know, all you got to do to climb that tree is blah, blah, blah. Or, hey, I can tell you how to rig that down, listen to me. Everyone has had to go through that, okay? Or I know how to water my tree. So that's the Dunning-Kruger effect. So the Dunning-Kruger effect is just, it's all about self-awareness and what you don't really know. Okay, the next line of evidence is, and I have to follow along now. Boop, boop, boom. Some friends and I had noticed that scientists were writing articles and books teaching other scientists about climbing, and a lot of the information that they were publishing and writing about was not really good information. And so if we take this, any kind of unsafe information that was written as material to teach tree climbing would kind of give me a hint that maybe the author doesn't know as much about tree climbing as they think they do. So if we click on the slide, some friends and I wrote an article that was published in a really top journal called Methods in Ecology and Evolution. And if we click on the slide again, we get a yellow bar across there, because the point of highlighting the authors is the first author on the left, David Anderson, is yours truly, a scientist. The authors to the right are Will Kumjian, Brian French, Scott Altenhoff, and James Luce. And who are these guys? Professional arborists. This was teamwork between a scientist and arborists to figure out how well scientists climb trees. What did we do? We click on the slide and we see what we did, and we click again. We did online searches of databases that scientists have access to. And we looked for the words canopy access, because this is how scientists start out, by looking for information if it's already been published. I'll go on my computer and I will type in canopy access and I will get some articles back. Okay, that's what they do. And we found 54 books, articles, and book chapters that had those words in them. From those, click, we kept 25 articles, because those of the 54, that was 25 that were supposed to be teaching about tree climbing. And from those 25 articles, we looked for what we called safety deviations. Safety deviations fell into two categories. Minor safety deviations were those that expose a climber to an unnecessary risk, and we had 5 categories. Two of them are, one here is where we have a photograph that was published and it shows a bunch of screw gate carabiners. So the photograph is by demonstration suggesting that inappropriate equipment options like screw gate carabiners are okay for tree climbing. The second minor safety deviation was blurring the distinction between a fall arrest system and a work positioning system, telling you that maybe climbing in a tree situation, you need to protect yourself from falls. And every good arborist knows that it's all about work positioning. You're not supposed to fall when you're on rope. So those are minor safety deviations. Star on the slide, David Anderson remembered. The next one were the major safety deviations, and these were recommendations that could result in serious injury or death. And click. This is the photograph and the article that broke the camel's back. Will Kumjian and I saw this when it came out, and you can read what the authors wrote. Free climbing large trees is possible and can be accomplished safely. The person is trailing a rope, climbing in spurs, wearing a lacrosse helmet, and the tree is too big to even get their arms around. So this article, I mean, I don't know what's safe about that. I'm not sure which part of that safety I don't understand. So free climbing and proposing methods that could lead to a dynamic fall are examples of major safety deviations. Okay, so next one, we click there. And I've got to follow along too, so pause, just bear with me, people. We got two, I'm looking at 2 monitors. No, don't know about all of you. 84% of our sources had references to minor safety deviations. There were 98 incidences where they said something that was we called a minor safety deviation. And in the next one, there were 72% of the articles or book chapters had major safety deviations. So we found 67 references in 18 of the articles. And the next one, click. Oh, back one. The age of the source did not matter. We kind of thought maybe we're being unfair. Maybe it's only the old stuff, because we had articles going back to the 80s. Maybe it's only the old stuff that's just got outdated material. But we did some statistics on that and found that even the new articles are coming out and proposing unsafe methods. This tells me that scientists are not using good methods to climb. So, yeah, so the next question is line of evidence number 3. We kind of went through the back door in that second question. We didn't really talk with scientists to their face. We just looked at stuff that they had written and tried to interpret how much they knew about tree climbing. So we thought, let's ask scientists around the world how much they really know about tree climbing. Let's go to them and find out from them. So next, click. What we did was a global online survey as a partnership between Boise State University and the Peregrine Fund, who pays my daily paychecks. And in this global survey, we looked at 5 skill categories and Will Kumjian is a lead author on this paper as well, that we figured would really separate the best from the best and would help us identify where a person fell on their tree climbing expertise level. And those were climbing tall trees, line installation, what methods did they use for installing trees and how high could they install lines in trees? How much did they know about methods and equipment options? How much did they know about lateral movement in the canopy? Because when I was climbing on stationary rope systems, I would just go up the rope and hang out, and that's all there was to it. Forget about branch tips. And aerial rescue are working with a small group of scientists in remote places. You better know something about aerial rescue. And the first question that we asked on the survey was, is tree climbing important to your research? Because if a person is a marine biologist, we don't need to talk with that person, right? they just kind of get disqualified and booted out. But if they said, tree climbing is important to me, I climb trees for my research, then they were in. Okay, next slide. Here's some example questions, and I'm going to have to zoom in on my screen so I can read some of them. One of the questions that you can see is, what is the greatest height in a tree at which you have ever installed a line, meaning the climbing line, throw line, fishing line, or some other line for aid in climbing? And we gave them 4 choices: 50 feet, up to 150 feet, up to 250 feet, and beyond 250 feet. And someone out there is going to say, this guy's full of it. No one can set a line at 250 feet. Yes, it can be done. Next slide. And then we had this question where describe your experience accessing each numbered zone of the illustration below. And the tree is divided into 4 zones. Near the trunk, mid-branch, branch tips, and the open spaces between trees. And if we click on that one, they have 4 different ways they can answer for each zone. I rarely or ever access this zone, or click, I can get to that zone, but I need someone with more experience than I have telling me what to do. Or the third one is, the third click is, I'm able to access this zone. Kale, the third click is, you're there, I'm not, sorry. Sorry, everybody. I've got 3 screens, so I'm confused. Kale's on the ball. The third one is, I can access the zone with help from someone who has less experience than I do. I tell them what to do. And the fourth one is, all by myself, I can go to all 4 places in the tree. Now, if we go to the next slide, this is what it looks like inside the black box, everybody. Just to show you that there's a lot more happening to this computer survey than just asking the questions. Every question has a rubric, and it starts to get really complicated. And then what happens next in science? Yes, ha ha ha, just like the song, right? This slide gets a little complex, so I'm going to have to zoom in on my screen. Those are the skills that we mentioned: setting lines, accessing different parts of the tree. And let's look at the upper right panel. Oh, and I forgot to say, another way that arborists helped with this survey, so Will Kumjian helped think of the survey, design the questions, but he also picked some friends who are top arborists in the Pacific Northwest United States and Pacific Southwest Canada, who are considered some of the top arborists in climbing tall trees, and asked them to take the survey. And we got their answers as like super high level expertise that we could compare with what scientists are doing. And in all of the different plots on this graph, you can see that arborists are shooting way higher than scientists. Only a few of the scientists ever surpass 50% on the skill level, just to make it, simple language. Almost all of the responses are from below that 50% level. And I didn't say, when I called this a global survey, we sent it all over the world. We sent it on Facebook. We sent it every way you could. It was translated into 4 languages. So you didn't have to speak English to take the survey. You could speak French in Africa or Europe or Spanish or Portuguese or English. So it's truly a worldwide effort. Okay, let's go to the next slide. So first of all, if someone were to ask me, are scientists very good at climbing trees? The answer is no. Scientists told us how bad they were at climbing trees. We didn't have to interpret it by what they wrote. But there was this other question that is going to be fun, thinking specifically about your skill set and the work that you do, rank your level of expertise in tree climbing. And there's a wink, wink next to this one. Can you see where we're going? This question came out at the beginning of the survey before they saw the questions that might influence what they actually, how good they thought they were. So we were able to get their perspective on how good they were, and then we crunched the numbers and found out how good they were. And let's go to the next slide and the next slide. We'll skip that one. Go to the next slide. Yeah. Here, and one more click. There should be two graphs. There we go. The graph on the left is the original illustration from that paper by Dunning-Kruger that shows the Dunning-Kruger effect with the two lines that cross. And the figure on the right is the one that came from our data. They're almost exact replicates of each other. And what it means is this well-known psychological effect of people overestimating their abilities is true for every kind of field, including tree climbing. No surprise. So what does that tell us? Scientists, on average, are not good in tree climbing. And at the bottom of the screen, it says overconfidence is high. They think they know more than they do. And again, I used to be one of those people, and I often go to meetings where you will have 600 scientists in a hotel. And I will talk with them, and they will say, I climb on Jumars. I know everything there is to know about tree climbing. Thank you very much. So maybe not. All right, next slide. But I'm gonna have to put my glasses on because I can't even see. So the moral of the story is scientists arborists are really important in helping us answer these questions. And the next story tells us that as well. Some scientists are really good tree climbers. I can't say that all scientists are bad. And this person is a friend of mine. Her name is Sybil Gotch, and she works at the Franklin and Marshall College where she studies epiphytes. And here she is in the top of a tropical cloud forest in Costa Rica. So to make sure that we're all on the same page, I want to talk to you for a minute about epiphytes. Oh, and there's 2 stars on this slide. Wink, wink. I better look at my notes. Epiphytes are plants that grow on other plants. That can be a moss. In the southern United States, it can be Spanish moss or the ferns that grow on the trees. If you're in California and you look at redwoods, there are huckleberries and sword ferns and even other trees growing in the tops of the trees. Epiphytes are so common that most of what you see in this photograph are not leaves of the tree that Sybil is climbing in. It is the epiphytes in the tree. She works in a reserve called Monteverde Cloud Forest Reserve, and in this one small private reserve, there are over 800 species of epiphytes just in this one place. And it is estimated that if you took 100 square meters or 100 square yards of the Monteverde forest, you would have 2 tons of epiphytes in that 100 square meters of forest. Meaning if you were to strip all of the epiphytes out of that forest, you would leave a desert. It would look more like a city park in Boise, Idaho, where I live. So at least 35% of all the leaves and 45% of all the nutrients in the canopy of that forest are epiphytes. And epiphytes have a really important role in the ecology of the forest. They capture and retain water as it's falling from the sky, or they intercept moisture in clouds and they trap that water, and the water percolates through the epiphytes down the tree, into the ground, into the streams, and into every human, village, city, and town that is downstream from the mountain. They make and retain their own soil. They're little soil factories up there. And because of all of the different types of plants that grow up there that are epiphytes, they are habitat for lots of wildlife like frogs, birds, insects, and even crabs can live in the tops of the canopy. And some examples of canopy epiphytes are orchids, like the vanilla orchid. Who hasn't had vanilla before? So, maybe in the morning you had a cup of coffee with some epiphyte flavored creamer in it, that was vanilla. And cacti grow a lot in the tops of these trees because it's a drought condition. If you don't have water and it's sunny, it's dry, and a cactus needs it to be dry, and they grow in the tops of the forest. So epiphytes really matter. Without epiphytes, you would be losing habitat for lots and lots of species. That's why epiphytes are important to cloud forests. And they are super common, and they grow absolutely everywhere. Okay, let's click through another slide and see what we get. This is Sybil doing science in the canopy, and science rocks. And Sybil is not only a good tree climber, she is a really good scientist. She has devices, and I think that's what this one is doing, that she puts a probe into the stem of a plant and she can measure the flow of the sap under different types of meteorological conditions. So is it daytime or nighttime, sunny or cloudy, rainy, misty, December, January, June, July, or whatever, and understand how much water is actually flowing through the canopy at any point in time. And she's up there on rope making this work happen. Again, here's another example. You can't do this work from the ground. Birds, plants, doesn't matter. You got to get into the tops of the trees. Next one. But it's arborists who make Sybil's work not only possible, but better. Okay? Pictured in this slide are some friends of mine and some really good arborists. Tyler Juni Zuniga is on the left. On the right is Will Kumjin, and not photographed is James Luce. How have these guys helped Sybil with her work? Well, Sybil was climbing on a yo-yo or a rad system, if I remember right, when they got there, and they taught her to climb on single rope or stationary rope. They taught her crew aerial rescue methods, okay, because they're working on a mountaintop in Costa Rica and they didn't have aerial rescue methods. But there's more than that. Will's photo on the right, he's looking kind of thoughtful, because if you know Will Kumjin, he's a very thoughtful kind of guy. And he's figuring out how to cut off this branch and rig it to the ground. Sybil got a special permit to collect a few entire branches from the tree. And she wanted to identify every epiphyte on the branch and weigh them and know how much they weighed. And then she could extrapolate and say, how much weight is in this tree? How much weight is in this forest? If a scientist like myself went up there, I'd cut the branch off, it would fall to the ground, the epiphytes would explode everywhere, and it would be a failure. But Will and Junie are, rigging these branches and lowering them to the ground. So Sybil gets a lot of credit for being a scientist, but behind every good canopy scientist, there are at least 2 good arborists. Famous saying, put that in your notebook, okay? Thank you very much. Okay, what happens on the next slide? Okay. There are lots of places in tropical countries that look like this. Vast tropical rainforests with hardly anybody doing anything there, let alone canopy science. How do we make sure that there are people who can work in forests like that? Well, we go to the next slide. We do international climber trainings. Starting in 2016, James Luce there on the left, and I started developing a program of international climber trainings. In 2016, we did a 1-day workshop at a scientific conference in Costa Rica. And you've heard the saying, fake it till you make it. That was totally us. We had a few friends like Nick Bonner who donated some equipment and some advice. Nick said, you got to have a rope wrench. And I thought, we don't need a rope wrench. And he goes, I'm sending you a rope wrench. It worked. Anyways, we didn't have enough equipment for everyone. We didn't have enough helmets. It was just enough to get everyone familiarization with what it means to climb a tree, get them up to a tree, and get them excited about future tree work. And it was good experience for us to learn what it was going to take to do these better in the future. So on the next slide, in 2017, we hooked up with a nonprofit conservation organization in Colombia called ProAves. ProAves studies birds. Their name literally means for the birds. And one of their specialties is endangered parrots, some parrots that are on the brink of extinction, like this close to extinction. Where do parrots nest? In tree cavities. How do people get up and study parrots in the cavities, or even build artificial cavities so that the parrots have more nest holes they have to climb? So James Luce and I went down to Colombia. It was really a hardship. No one wants to go to a tropical forest and climb. I promise you it's awful. And have lots of fun. What I meant to say, suffer through a week of working with these dynamite, excited, super talented guys, teaching them tree climbing. If we click once, we have a Christian is climbing a palm tree, and he's hoisting up a nest that was made out of bamboo, and he's showing his co-workers how to climb a palm tree and how to tie an artificial nest to the side of a palm tree. Click one more time. Here, another technique that we used for teaching in the international climber training was we would teach a small group of guys and then they would teach the others. So Christian took what he learned from James and I. Here he's tying a figure 8 follow through and he's teaching the other guys. And you can see they are really paying attention. These are guys with very little education. High school, maybe less. And they are totally into it, and they were really good with their hands and really good at climbing. So so there we see a guy with a red helmet and a guy with a blue helmet. On the last day, we gave them the ultimate test in how confident are you as a tree climber. We took the top students and asked them to teach their bosses how to climb. These bosses had not been in the tree climbing workshop all week. It's Friday. If you know anything about authority and respect in Latin culture, there is a lot of respect for authority, okay? To teach your boss how to do something and literally put his life on the line is huge. And you can see from the smiles of these two guys, Alejandro on the left and Eduardo on the right, that they nailed it and they had a blast. Alejandro on the left was the park guard who was teaching his boss, Alejandro, how to climb on a rope wrench. From the beginning, how to inspect a tree, how to tie your basal anchor, and everything from there to the top and climb on a rope. It was really good. Okay, what happens next? Well, what are the kinds of things that students learn in our international climber trainings? Felipe on the left is learning how to install a line in the tree. Go back one. On the right, you can see there's some instruction on how to tie knots. Celeste is a woman in the red shirt. She tied a knot. Someone else is taking a photo of the knot. But we have, each time that we teach one of these classes, oops, there's a yellow star there. So they learn basic skills like line installation, tying knots, and next click. We have our curriculum so dialed in, one more, that by the 5th day, we have students doing limb walking, 50, 60, 70, 80 feet off the ground, going out on these branch tips, because we know how to build their confidence and their skills and supervise them and get them doing these types of skills. And it's really satisfying. It's really satisfying to take a group of people who have never climbed a tree before with a rope ever, and by the end of the week, they're doing that. Okay, click one more for me. But there's another lesson that students learn. And if I get through it, I'm going to tell you a more essential lesson that is even more important than knots or line installation. These students learn a sense of appreciation and gratitude for strangers and foreigners who are willing to donate equipment and money and time to come down and teach them tree climbing. And Jose in the left photo at the end of the week, can you believe he said this? You'll have to read it because I won't make it through. But this is what Jose said at the end of a week. So our students literally say it was one of the best experiences of their life, that it made them a better person, that it changed their perspective on the natural world and on themselves. Who doesn't want to be a part of that? It's incredibly rewarding. Next slide. In 2019, we had our most ambitious tree climbing, international climbing ever. We had 20 students who came from 7 countries in Latin America, all the way from El Salvador and Honduras to Brazil. We had 4 instructors who were all bilingual. And to show you the type of teamwork that it took to make this happen, I'm going to go through, the instructors in their photographs. On the left is James Luce, a certified arborist. One more to the right is myself. David Anderson, a professional scientist. The guy in the tree is Patrick Brandt, rescuing a cat. Patrick is not only a PhD level scientist, he is also an ISA certified arborist. And then Emmett Lawrence on the right. So out of 4 guys, we have 2 scientists and 3 arborists. That's what it takes. That's the kind of expertise that it teaches and partnership that it takes to teach one of these classes. Thank you. And then one more click. So we taught this course at the Rio Claro Nature Reserve in Colombia. Another terrible hardship. The water is crystal clear in the river. It's a limestone river. You can see right through it like it's glass. And, you know, when you're hot at the end of the day, you have to go swimming. But the photo shows you the sense of family that we create at the end of a week of one of these activities. People are happy. And I kid you not, the sense of family is so strong that there are a few tears when people have to go home. Darn it. What's the next slide show? I got to escape. Yeah, the Rio Claro Nature Reserve. So here we have a photo of one of our students limb walking again. And then the next click. Here's 3 students climbing a tree that's about 130 feet tall. That takes a lot of confidence building and a lot of skill to get to the top of that tree. So I'd say it was a success. One of the objectives of our training, I'm catching up on my screen, is to make canopy access durable in Latin America. It's not enough to teach a class about how to climb trees if none of the equipment is available. In 2019, we actually donated 11 complete climbing kits. 5 went to the top students in the class, and 6 went to our partner organization, Fundación Alianza Natural. They have 6 kits that they can use to continue to teach tree climbing and do research in Colombia. And the next slide is beautiful. When I say we donated kits, I mean the whole thing. The backpack, the ropes, the helmets, the PPE, carabiners and lanyards and sequoia harnesses, and the whole thing. It takes a lot of people to pull off one of these trainings. So one click. Fundación Alianza Natural was our partner in Colombia. We had a university, Universidad del Bosque, Reserva Natural Rio Claro, and one more click. Okay, stay there. Anyone who's an arborist and is the head of a business knows you have to have hardware and software to run a business. There we go. Hardware is like your computer, keyboard, one of these, right? Software is your billing stuff, you know, software. Okay, well, we had an official hardware sponsor. That was Petzl Foundation. They donated the helmets and lanyards and carabiners. Yale was the official software, I mean official, like in writing, software sponsor of our training. And one more click. We had over 20 partners who came in on this. Kevin Bingham from Singing Tree, and Wesper, and Cheryl Tree, and DMM, and TreeStuff, and Tienda CPP, which is PPP in Spanish. And one more click. Ruppert Foundation came in with the money to pay for things like airfare. And if I didn't make it clear, we donate these trainings. We charge a small fee to make sure that students are interested in coming and they don't want to just have fun climbing in a nature reserve. But other than that, a week in the nature reserve and everything else is free. So one more click. We had over 20 partner organizations to pull that off. All right? That's what it takes to do a tree climber training. International style. So some lessons from this story. It takes a community to climb a tree. It takes a community to build a tree climber. It takes dedication, money, and enthusiasm. It takes good people like you out there to partner as arborists and experts and to provide the equipment and the funds. We even had a t-shirt campaign in 2019 to pay for this. We had to raise, $2,500, and we pulled it off. And everyone who bought a shirt for Canopy Watch, thanks to all of you. If you want to see some more of that training, let's see, did I go back one, Kale? The hashtag Docel Colombia 2019 or hashtag Discovering the Canopy. You can go to Facebook and Instagram and see photos and read stories in English and in Spanish about discovering the canopy. And then we click one. Discovering the Canopy 2020 is the next slide. Not going to happen. Something crazy happened to the world this year. It was on the books. We had the money, we had the equipment, and we're going to postpone for 1 year, and it's going to happen in July 2021. So if you know any aspiring students or biologists in Latin America, they can get in touch with me, and they can submit an application next year in the spring to come to Discovering the Canopy 2020. All right. I set out an hour ago with the mission of explaining to all of you what canopy science looks like, why canopy science is necessary to understand the natural world, and that canopy science is a blood and sweat partnership with arborists and arboriculture and arboricultural businesses like TreeStuff, thank you very much, and Petzl and Wesper, and so many more. One more click. You should be able to see a website for Canopy Watch. I'm going to invite, shameless plug, but partly for education, go to canopywatch.com. The blog I'm kind of proud of. You will read fun stories about sleeping in tree boats in Washington State and the Dominican Republic. You can learn about the ecology of rainforests in the Olympic Peninsula to Costa Rica, and inspirational stories about why it really helps to take non-tree climbers on a tree climb. And there's a donate page, because if you want to support the work that we do, because everything is not for profit, 100% of every penny we raised goes to teach people, like in the next slide, how to climb trees so that they can do research and conservation in the countries where they live and where nobody else is doing that work. Thanks, everybody. I'm a little tense, but thank you very much for listening. Lots of acknowledgments for everyone who has inspired me or helped in some way to make international and local tree climbings possible, including arborist friends like you everywhere. Thanks a lot, everybody. Done with the slides, and I'll take questions.
Hear me. All right, I'm going to give everyone a few minutes here to see if they have any questions about anything, whether it's relating to your experiences with arborists or what Canopy Watch does, because they're on a little bit of a time delay, just because of how the internet works. So we're going to give them a few seconds. I do have one question here. How fluent are you in Spanish?
Pretty good.
Okay.
Yep.
All right, let's try it, because high school is the last time I spoke Spanish, but we've got, I think this was going back from I'm talking about epiphytes, ¿Cuánto sería un mínimo de árboles para un estudio de serio de epiphytas?
Yeah. So I'll read it in Spanish once and then in English once.
Yeah, that's Carlos
and
Funes.
In Spanish,
that.
Carlos Funes. Oh, yeah, that guy. I knew you were going to get me. ¿Cuánto sería un mínimo de árboles para un estudio de serio de epiphytas? So how many trees do you need to do a serious study on epiphytes? There's no easy number, because it really depends on the question. There have been epiphyte studies in a single tree, and there have been epiphyte studies in, dozens of trees or more. So it depends on if you're looking at maybe on the side of a mountain on the elevational scale, you want to look at the differences in epiphytes that grow high elevation versus low elevation. You have to have more trees. If you just want to know how many birds are visiting a single tree, eating fruits and drinking nectar from a tree, maybe 1, 2, or 3 trees. Yeah. Thanks, Carlos. Picaro.
Oh, sorry, you couldn't hear me there.
No.
Um, I have a few questions. One of them is when you're doing your surveys up in the tree, um, and you're up there for what you said 3 hours at a time doing. How often is it that you go, oh, I don't recognize that bird? Do you have to have a book with you to look it up? What's the process there?
Right. So the question is, what is the process for identifying the birds? Because I had almost 5,500 detections of 165 species, and you have to learn those species by sight and by sound if you're going to do a competent survey. And it's um, a lot of field guides. There are field guides to Costa Rica, Panama, Honduras, and there are apps you can get on your phone. You can get an app that has recordings, and you have to study up, and it helps. Sometimes you can record the bird with a microphone, like you're hearing it and you don't know what it is, so you record it with the microphone, and then eventually you're going to see that bird singing, and you can go back and replay your stuff and record your surveys and identify that bird and fill in the blanks. But it takes some pretty good bird skills to pull that off.
What you talked a good amount about how scientists are not the best at climbing. Is there any sort of what have you done? I guess in the more major, along with Canopy Watch, of trying to correct the scientific community on how to
Oh,
properly. Um, have you written papers on your own on how to do so?
okay, good question. So, first of all, scientists on average are not good tree climbers, but some scientists are really good tree climbers, like the best of the best tree climbers that you can be. Some of them are scientists. But on average, scientists are really bad. And it's kind of a personal crusade of mine um, to help scientists be better tree climbers because to I want scientists to under I want scientists to create a better understanding of the natural world occurring in the tops of trees. And the way that I do that, I published one paper, the one that was highlighted earlier with James, Will, Brian, and Scott and myself. We have a second paper right now that is in review in a scientific journal. So scientists will read it. And that in that paper, we're saying scientists are not good, but they think they are. And I give tree climbing workshops at conferences. So just like there's arborist conferences, there's science conferences, and I can do a 1 day climbing workshop just enough to show scientists, like, here's a whole bunch of methods. Maybe you didn't know about all of these methods. Um, you're going to get a run through, and then if you have more questions, find us later and we'll help you learn more.
Awesome. Um, all right, we've got some questions here, and I apologize. I can't see the names of the people when I'm putting them up here. I don't know what's going on with that. But someone's asking here, are there opportunities for non-students to get involved with Canopy researchers?
Oh, are there opportunities for non-students? So some there's a branch of science we called citizen science. And citizen science are science projects conducted or aided by non-scientists. So an arborist or someone with good tree climbing skills can volunteer for an agency like the Forest Service maybe, and create habitat in the tops of trees by making snags out of trees, um, by installing cameras in the tops of trees, or being a trainer or being an assistant on a scientific project. So they're finding those opportunities is hard. And maybe I should create a page on the Canopy Watch website where I can put people together like scientists and arborists, or, volunteers and scientists.
That'd be
So
awesome.
there are ways, if you look hard enough, you can find them. Yeah.
Okay. I think there's a few questions like that. Um, yeah, how do arborists? Yeah, if you could set that up, I can definitely advertise that on TreeStuff and get people interested.
I just
Uh,
invited myself to do more work.
exactly. Um, Here we go. Someone asked, how did you gain the trust of the participants uh, initially who come down for the Canopy Watch events?
We have little activities about building trust. There's kind of team building activities that you do regardless of what your overall goal is. Um, and then honestly, you build trust by the old saying in learning to climb trees, go low and slow. Um, we're teaching students to climb on rope wrenches, and we teach them on the ground, and we do a lot of teaching on the ground, and then a meter, or 3 feet off the ground, and just going up. And interesting things happen when you are getting someone you don't know to put their life in your hands and in their hands. It's a pretty quick way to build trust. And some people build self-confidence faster than others. And that's a part of our process. Honestly, if someone comes out of the week and maybe they weren't the best tree climber, but their self-confidence is a lot higher than it was, I say that was a win-win. Yeah. More questions?
Oh, sorry. I keep muting myself so you don't hear my weird mouth noises. Um, Someone here is asking, how do you stay comfortable in a tree for 3 hours?
Oh, man, you're not sitting in a harness, I'll tell you that. Um, you have to find a good place to sit. So picking a tree for a 3-hour bird survey is really hard, and I might have to climb 2 to 3 trees before I find one that works. For a tree to work for a 3-hour bird survey, it has to be taller than all the other trees around it. It has to be an emergent tree so that I can see at least 100 meters or 300 feet in all directions. Um, it has to have a comfortable place for me to stand or sit. So there will be multiple branches that I can lean on, sit on, change my posture, and I'm like moving around, and I'll be hanging on the rope, excuse me, or hanging on a lanyard or whatever. And then when I'm up there, I'll take off my helmet, I'll hang a notebook and some snacks. I'll have a backpack. The backpack's got water, sunscreen, a hat with a brim on it so I don't get scorched, because the tropical sun is brutal when you're in the top of the forest. Water, snacks, a recorder for my notes, you know, my cell phone, because sometimes standing on the ground, you don't have cell signal, and then you climb into the top of a tree and magical things happen and you can reach a cell tower. Yeah.
Uh, I think on the same vein of questioning there, how many times have you been attacked by birds or animals while in the tree?
This, yeah. How many times have I been attacked by birds or animals? That's the funny part of climbing for science. When you do your pre-climb inspection, one of the things that you're looking for are animals that could be dangerous. And a lot of times when you're a scientist, you are climbing a tree because you want to capture a dangerous animal. Does that sound strange? It is strange, but it is true. So goshawks are a good example. A goshawk, look that one up, Goshawk, are a really beautiful bird. The adults are gray and black, and they have red eyes. And it's the red eye that tells you they're mean and tough. And if the adults are flying around, the female will try and take your head off. And she's got big claws. And so sometimes you do get attacked.
And that's
The scariest thing for me in a tropical forest are the Africanized bees. And sometimes I'll be sitting in the top of a tree and a swarm will fly by and you'll hear it coming and you'll just hear this loud buzz. And the whole swarm flies by and you just like sit still and hope they don't stop in your tree.
okay. You were talking about discovering new species. Do you have any sort of estimate of how many new species have been discovered through arboreal canopy surveys?
I don't. I love that question. How many species have been discovered through arboreal tree work? Two of the scientists who took our class in 2019 discovered a new species of orchid and it lives in the canopy. But this is a secret. They discovered it while standing on the ground. But they can now climb into the canopy and get better samples of their orchid. But I don't have a number for how many species. But I will tell you this. I guarantee you that if we can get more scientists in trees, we will discover some new birds, new plants, definitely new herps. So herps are frogs and lizards and snakes. Absolutely 100% for sure. Those things are out there waiting to be found.
Cool. And this is my own question here. Do you have any advice for any things that arborists can do while they're just climbing to look at species that maybe to notice? We deal with a lot of invasive species coming in. So, like, any techniques to look for something new that they haven't seen before, to notice that? Do you have any?
Yeah, I would say the whole secret is just slowing down. It's easy to be in work mode, whether you're a scientist or an arborist or whatever, and you're thinking, go, 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 go. And you don't appreciate the moment until you slow down. And sometimes when you just like, oh, man, I'm going to enjoy the view. So my friend James Luce, he talks about if you're going to take down a tree for whatever reason, and you get to the top of that tree and the view is incredible and you for a moment you're breathless, stop and enjoy the view because that view is never going to be seen again once you take that tree down from the top to the bottom. So just slow down and look. And you'll start to see things that you didn't notice before. And there are some really good smartphone apps that like iNaturalist, and there's some for Leaf Snap and some others, where you can take a photograph of something and submit it through the app, and someone somewhere will identify that thing for you, whether it's a flower or an insect. I've seen species of geckos in the tops of tropical trees that I've never seen on the ground. And like, I'll go to the top of this tree and there that thing is, And then a year later, I'll climb another tree and there it is. And I've never seen it from the ground. But you got to get up there and you got to take the time.
Sorry, I was downloading that. We have a question here. Why are you teaching people on the rope wrench? Is there a specific reason for that?
Okay, why do we teach people on the rope wrench? We needed a versatile tool that would allow people total canopy access. So from the bottom to the top and walking out on the branch tips. We needed a system that would allow them to get out of the tree if there was an emergency without having to change systems. And the rope wrench is just a tool that um, we're comfortable teaching, and it works really well for all of those things. And we just feel we have the confidence. When we teach tree climbing, we want our students to know right from wrong, and we teach the minimum level of skill necessary to get up the tree, out on the branches, and back down. We don't try and teach a lot of knots, only the essentials. They don't have to know everything to climb. They need to know a few things to climb safely. And and we decided after our second tree climber training that a rope wrench is a system that works really well. It meets all of our objectives, and we can get them to learn it well and learn it safely.
Is
It's
there?
smooth. I love it.
Sorry. Um, yeah, most people do love the rope wrench. We sell a lot of them. They're very popular. But I was wondering if like that's. Have you talked with other scientists who have different views on what the best climbing system is?
Oh, hey, wow. That's like asking what is the best beer or what is the best baseball team, or, every person has their own opinion about what is the best system. And it really depends partly on where you work. Like, are you climbing trees that are super pitchy? You might need to do something different. I might not, I might use a zigzag instead of a rope wrench. Oh, so everyone's got their own opinion. Another reason we use the rope wrench is because it's midline attachable. And for some of the work that scientists do, sometimes you got to disconnect from the rope and, reconnect from the rope and take your system off the rope and put it back on the rope. And some systems, if you're 100 feet high, you don't want to pull 100 feet of rope through, do your stuff, and then put 100 feet of rope back through your climbing system.
That is true. Um, when you are climbing, are you usually climbing solo into the tree to do some work, or do you have a team working together?
Um, if you have enough money, you can pay to have a team. Getting money for science is tough. The less money you have, the fewer people on your crew. It's always safer to have two climbers, two people who are trained in climbing and both have kits, or at least have a rescue system set up if someone in the top of the tree does get attacked. Um, so I recommend working in teams, but if your expertise is better, you can push the envelope a little farther. And then one of the dangers, I'm going to tell a story. Let's just make it fun. One of the early questions was, have you ever been attacked? The epiphytes in tropical trees are so full of insects, you could not believe all of the insects living in those things. There are many, many species of ants, and there are different kinds of bees that live in the canopy, and wasps. Some of the bees are sweat bees, and they like to fly into your helmet, and then they like kind of grab you by the skin, but they're not really stinging you, but it's a nuisance. They just get in your helmet, and now you're swarmed by bees in your helmet. I once climbed a tree that was so big that it had trees. Actually, happens more often than once. You can climb trees that are so big that they have trees growing in them that are bigger than the trees growing on the ground. And I climbed one of those trees once, and I got attacked by ants, wasps, and bees all in one tree. No birds, but it gets prickly sometimes.
Oof.
So one tip is tuck your pants into your socks when you're climbing a tropical tree and spray your socks with DEET insect repellent.
Definitely. Um, Boy, I got a few more here. I've got one person. What would you tell a mid-career forest ecologist who wants to move their research up into the canopy, especially this summer with all the COVID restrictions?
With all of the COVID restrictions, well, That person doesn't say how much they know about tree climbing, but I would get an instructor, and I would get someone who's going to work with you and teach you tree climbing, and I'll teach you a lot of tree climbing. And that's another reason why I want scientists to know more about what they don't know about tree climbing, because you can go on the internet and find lots of tree climbing instructors, and you start to look at their photos and you see maybe their knowledge of methods and equipment and safety are not all that good. So I would say get someone who's going to work with you, spend a lot of time with you, and make sure that person really knows the difference about uh, good tree climbing and hack tree climbing.
Okay. One
And
more. Oh,
on the Canopy Watch website, there's one of those forms that you can fill out where you can email me, and depending on where you live, I might know someone close to you, because obviously I don't live in North Carolina or Oklahoma or a lot of other states, but I might know somebody near there, or I might be able to find somebody.
okay. Um, that's definitely something I will recommend is going to canopywatch.com and looking into that. I read some of it a little bit ago. It's super interesting, super cool, a lot of resources. One last thing, what plans do you have in the future for doing tree canopy surveys for yourself? Where are you going?
Wow, I'm not doing as nearly as much tree work as I would like. Um, when I get tense at my job all day, I'm like hunched working on a computer, and then I go climb a tree and reality sets in and life is good. So right now I'm not doing a lot of tree work. I would like to be able to get into more canopy science. This year in January, I did get to work through the Peregrine Fund in Panama to film a documentary on harpy eagles. Harpy eagles are the largest raptor on the planet. I have skinny arms. I can wrap my finger and thumb all the way around my wrist. A harpy eagle has a wrist the size of mine, and they have talons the size of a grizzly bear claw, and they eat monkeys and sloths. And we were installing a blind in the top of the forest so that the filmmakers could photograph and film the harpy eagle. And there will be nothing this year that comes anywhere close to staying in an Indian village for a week on the Pacific, on a Pacific beach, hiking into the forest and climbing tall, lush tropical trees and looking at the largest, most deadly eagle in the world. That blows your mind. So if you can do that, hats off to you. If I can help you do that, I would love to make that happen. And if I can help me do that, then I would be a happy guy.
Yeah, call me the next time that you're gonna do that.
Okay.
Well, David, thank you very much for doing this. Um, I definitely enjoyed it. I think everyone else did. This might be. I don't have the count here yet, but we might have the most thumbs up and heart emojis for this one, as we have all of the webinars. So that's pretty cool. But definitely, everyone watching, thank you for paying attention. The quiz is currently up so that you can get your CEUs. Um, it is they've it's a little bit different now. You can get 2 CEUs within the next 24 hours for doing the quiz. After that, if you watch the recorded one, which if you're watching this live, it doesn't pertain to you, then you can get 1 CEU. So try to make it to the next webinar live. I'm going to switch to our little commercial break here in a second, and then we'll end it. David, thank you very much for doing this. It was super interesting, super fun, and wish you luck in all of your endeavors, and thanks for Thanks for doing this.
Thanks to everybody out there for watching this one live or afterwards.
All right. And we have a bunch of great webinars just like this one scheduled on our Facebook page, so make sure to RSVP to the Facebook event pages for updates. On May 14th at 6 p.m. Eastern Standard Time, plant healthcare expert Trent Dix will be talking about preparing for the newest invading pest in the U.S., the spotted lanternfly. This webinar will have a lot of important information about battling the spotted lanternfly, so be sure not to miss it. There will be 2 free CEUs available for attendees of this webinar. On May 28, we will be hosting a webinar on work positioning for safety with West Coast trainer Craig Bachman. 2 free ISA CEUs will be available for anyone who watches this webinar live. On June 25th, you can tune in to our webinar about aerial friction and rigging techniques, hosted by Rich Hattier. You can earn 2 free CEUs by watching live. Keep checking our Facebook events page to stay up to date with all of the great webinars that are on the horizon. Join us Tuesday, April 28th for 3 conference calls with Rich Hattier, discussing using dual SRT or SRS systems and what that means. There are 3 30-minute meetings that are available, but space is limited in each call. So go ahead and sign up on our Facebook events page. On April 30th, Lindsay Purcell will be hosting a free conference call talking about tree rot in all of its forms. There are 3 30-minute meetings, but each one has limited space available. To reserve your space, go to the TreeStuff Facebook events page.
I'm Carson with TreeStuff.com, and I'd like to ask you to take a second to learn about the Fallen Families Fund. It's a charity created to provide small cash donations to families who have been affected by the death or injury of a working arborist. All of the administrative costs are covered by Cheryl Inc., so 100% of your contribution goes to help families in their time of healing and recovery. You can learn more and donate at www.fallenfamiliesfund.org.
Geocaching is a fun tree stuff program based around searching for hidden treasure in the trees. Volunteer arborists from around the world have set caches in their area for climbers to seek out using GPS, their wits, and their climbing skills. To start geocaching, all you have to do is go to treestuff.com/treeocache and find a cache near you. We have a few new trio caches to announce. Brandon Othen of Arizona has set Trio Cache 87 near Phoenix. Sid Howells of Social Climbers in the UK has set up 2 trio caches, number 108 near Southampton and number 109 near Guildford. If you'd like to find these caches or any of the other caches around the world, you can request the coordinates at treestuff.com/treocache. The North Carolina Tree Stuff Party has been rescheduled from April until August 1st. It's hosted by Nick Johnson in Waynesville, North Carolina, and will go from 9 a.m. to 3 p.m. Has been rescheduled for September 5th and is being hosted by Jason Dudek. You can find more information on the Tree Stuff Facebook events page. For more information and addresses, head to our Facebook events page.
You can also get more information about these and upcoming TreeStuff parties by going to treestuff.com/parties.
Keep your mouth shut and your ears open. You've got to truly humble yourself every day and realize that one bad decision will be your last if it's the wrong one.
Never stop learning.
Learn and study a good arborist as much as possible. Watch them, watch how they work in a tree.
You know, get their 2 cents, especially in business. That's been the biggest challenge for me is finding out that a relative degree of skill will not carry me through, that I needed to be diligent as well about the business side of things.
If you haven't already gone to some sort of trade show, competition, whatever, get out and just shake hands with people. You'd be amazed how welcoming everybody is and how much they want to be there to help you. It's pretty inspirational.
Don't just take one person's advice, seek out as much information as you possibly can.
And also realize that it's not a single man sport. This is a team sport. It's a team occupation. And how we interact with each other and how we make each other feel is just as important as how great you can climb and how wonderful you can rate.
You gotta expose yourself to greatness. You don't settle. If you feel like you're gridlocked and you're not learning, move on and go find somewhere where you can learn and grow, So that's probably the best advice I can give. Soak it up like a sponge everywhere you can get it.